8.2 Similarity and Transformations. A similarity transformation is a dilation or composition of rigid motions and dilations. Now, what this means, first of all, we have this idea of a rigid motion. A rigid motion is a motion that is going to maintain the shape and size of the figure. So if I have a triangle and I just move it left, I move it right, I move it up, I move it down, I rotate it, that's a rigid motion. It's maintaining the integrity of the shape. It's just kind of like moving it around. That's considered a rigid motion. Now, a dilation, that is not a rigid motion. That is called a non-rigid motion. And the reason is because a dilation is then going to take something and make it either larger or smaller, which does not maintain the shape and the size. It would maintain the shape. It would still be a triangle, but it's either going to make it larger or smaller. So a similarity transformation is a transformation in which you have rigid and non-rigid motions taking place together. Then we have this idea of a similar figure. Well, a similar figure is a figure that has the same shape, but a different size. Now, more importantly, if figures are similar, then a similarity transformation exists that maps one figure onto the other. And we're going to be using that idea to actually prove whether or not figures are similar. Example 1. Graph triangle ABC with the vertices A, -4, 1, B, -2, 2, and C, -2, 1, and its image after the similarity transformation that's given below. So let's start out first of all with just graphing the points we're given. A is -4, 1. B is -2, 2. And C is -2, 1. And I'm still going to start with that one being a dotted line. And then I'm going to keep track over here. And then we're going to start with our similarity transformation. Now, the first one, we're going to do these in order, is a translation where we're going to take x, y, and we're going to take x, and we're going to move it +5, and we're going to take y, and we're going to move it +1. Now, really, what we can do here to get our next step is you can just take the x coordinate and add 5 to it, and take the y coordinate and add 1 to it. Or you can literally just take your A point on your graph, which is right here, and you can move it +5x, so 1, 2, 3, 4, 5, and then up 1y, and it's going to sit itself right there, and that's going to be our A prime. But if I'm adding 5 here, that tells me that A prime is really going to be at 1, and then add 1 here, and 2, which is exactly where we put it on the graph. Then we're going to do the same thing with B to get B prime. So I'm going to add 5, which is going to give me 3, and then add 1, which is going to give me 3. So 3, 3, which is B prime, and then C prime, we're going to add 5, which is going to give us 3, and then add 1, 2. So 3, 2, which is C prime. Again, I'm still going to keep this as a dotted line because I'm not done yet. This is not my final figure. And if I look at that, that's considered a rigid motion. It did not change the shape, it did not change the size, it just moved it to the right 5 and up 1. That is a rigid motion. Now we have to do our dilation, and it looks here like with the 2 and the 2, our scale factor is going to be 2, which is telling me for a double prime, I'm just multiplying by 2. So 2, 4. B double prime is going to be 6, 6. And C double prime is going to be 6, 4. So 2, 4 is A double. 6, 6 is going to be B double prime. And then 6, 4 is going to be C double prime. And then this one, I'm going to make a solid line. And that is considered your non-rigid motion because it did not maintain the size of the shape. It made it larger by a scale factor of 2.